So we need to construct a binary tree from the pre-order traversal given to us and the in-order traversal given to us. So we are given integer array called pre-order and in-order, where pre-order is the pre-order traversal and in-order is the in-order, and I need to construct the binary tree. Okay, so over here we know that pre-order is equal to the node first, then we go to the left of it and the right of it, and my in order is I visit the left, then the node, and then the right. Okay, so if we are supposed to write the pre-order traversal for this over here, so we write the node, this will be 3, then go to the left, and so this is node left r, node left r, let me write this, node left r, node left r, node left r. So we visited the node. Okay, now we came to the left of it, so now we visit the node, this would be 9, there is nothing on the left, there is nothing on the right, so we go back. Now we visit the right of this, so we have the node, we visit this node, so this will be 20. Okay, now we go to the left of it, on going to the left we have got 15, so we write 15 over here, we have nothing on the left, nothing on the right. Now for this we go to the right, so we got 7, there is nothing on the left, nothing on the right, and then we go back. So 3, 9, 20, 15, 7 is the pre-order as it is given here. Similarly we could do the in order. For in order it is left, node, and right. So this is, let me use some other color, left, node, and right, left, node, and right, left, node, and right, left, node, and right, left, node, and right. Okay, so when we start with this we go to the left, so we reach element 9, we go to the left, there is nothing, we write the element 9 over here, so that is the node, and then we go to the right, there is nothing, then over here it says n, so this is 3. Okay, then we go to the right, on reaching this it says L and R, so we go to the left, there is nothing on the left of 15, so we do nothing, and then we do the node, that is 15, followed by right, there is nothing, then we go back to 20, so we print 20, and then we go to the right. Upon visiting there is nothing to the left, we visit the node, that is 7, and there is nothing to the right, so this is, and upon coming back we visit the right, so this is 9, 3, 15, 27. This is the in order traversal. Okay, from these in order and pre-order traversal I need to compute or find my binary tree. Okay, so this is my pre-order and this is my in order, this is 9, 3, 15, 20, and 7. So I first compute the size of my pre-order and in order array or vector, so I get this. Okay, post that I will be using recursion to solve this. Okay, so I have my I over here which is set to 0, so at I is equal to 0 we got element number 3. Now we go and search for this element in the in order. Okay, so in order I got 3 at index number 1. Okay, so now this means this is node left and right, and this is left, node, and right. So now I've got the element 3, so this means the elements to the left would lie on the left of 3 and the elements to the right would lie on the right of 3. Okay, so we have over here 3, then this goes to the left of 3 and this goes to the right of 3. Now my I has been incremented. Okay, now my I is equal to 1. Okay, so now my I has been incremented to 1. Okay, so when we send this to the recursion, this has got only one element, so this would become a node and then return back. Okay, and when we go to and then we increment I, So my I is 2 over here. So now we go for 2, 20. So this is 20. So that means 15 is on the left of 20 and 7 is on the right of 20. So we call recursion. So 15 goes to the left and 7 goes to the right. Okay. So in this way I'll code and explain you in a better way. So I'll solve 105. So here my step would be to create a mutable variable I call 0 that will iterate over preorder. Now I call the solve function, send my preorder and then my inorder, and also my mutable variable I followed by 0 that is the low for inorder and the high for inorder that will be inorder.length minus 1. Okay, now I will write my function which is solve. So in this it takes preorder followed by inorder. Let me do this by reference so copies are not created. And my I, this is mutable of mutable followed by my low and my high. Okay, and this would return me a pointer, so I copy this thing. Okay, so if my low is greater than high, in that case I return none, that is my null pointer. And then I create a variable called val which will be the pre-order of I. Okay, and then I do I plus equal to 1. Create a root now. So this will be reference cell new, this will be tree node, the value I'll put in this. So if my low is equal to high, in this case I return my root. Otherwise I create a variable called k which is initially set to low, and then I run this while loop while low less than while k less than equal to high. So in this case if I'm able to find the value, then I will break, and post that I will increment my k by 1. Then I also create something known as left if k greater than 0. So for this I'll call the solve function, pass my pre-order, my inorder, my high will be k minus 1 in this case, else I do none. Okay, similarly I create something known as right. For that I call my solve function, I send my pre-order in order my I as it is k plus 1, and then comes high. Okay, then for these in the root, to the left of the root I put this left, and similarly for the right of the root I will put right, and then return this root. Where do we get the error? So over here my I, okay, I miss a comma over here. For my low is equal to high, in this case I return my root. Yes, everything seems fine over here. This should be root. this will be none. So I created the root, this is new, this reference, this will be reference cell.